Okay, so here we go. What's in control is this division bar. And then I'm going to rewrite this radical. That's a square root, so this is to the 1/2. And make sure everybody is in exponential form. So this becomes the log of the numerator subtract the log of the denominator. And of course then this is property 2. Now I notice that this is a product on the inside right here. So I'm not done. I can break this up using property 1 into the log of the first factor plus the log of the second factor minus the log of x minus 2 squared, and that's going to be property 1. Now if you look at it, everybody is a single factor, so all I have to do is bring the exponents down. So down, down, down. This is 3 log of x plus 1/2 log, it's more than one term, x plus 1 minus 2 log of x minus 2. And we're now in property 3. Everybody has exponents of 1. So x has an exponent of 1, x plus 1 has an exponent of 1, x minus 2 has an exponent of 1. So that's my final answer. So that if you think about the original problem, that's pretty ugly. When you're looking at this guy, he's going to be easy to work with because he's much, much simpler. He has no radicals. He has no exponents. He's just going to be a heck of a lot easier to deal with. Yes?
In the beginning of the problem, why did you circle it in parentheses and put the 1/2? Where did you get that 1/2?
Because it was a square root and I needed everybody in terms of exponents.
Okay.
And remember, square root is to the 1/2 power.
Okay.
Now this one's not particularly much fun. And I can go after them in a couple of different ways. I can look at saying that is something to the 2/3 power, and then I can bring the 2/3 down in front, and then I would break apart this guy. He's much more normal, if you can think of any of these things being normal. Another way that you could look at it is this way. This is x squared minus 1 to the 1 power. I can rewrite this guy as the natural log of x minus 4 and 2/3 times 2 to the 4/3 divided by x squared minus 1. 2/3 times 1 is to the 2/3. So use the property of exponents to clean this guy up before you start working with him. Now it's straightforward in that it's the natural log of the numerator divided by the natural log of the denominator. So the natural log of the numerator is it's x minus 4 to the 4/3. Subtract the natural log of x squared minus 1 to the 2/3. And of course that's property 2. bring the exponents down in front. This is 4/3 natural log of x minus 4 minus 2/3 natural log of x squared minus 1. This guy's done because the highest power here is 1. But there's something I see here. What's x squared minus 1? Yeah. So this becomes 4/3 natural log of x minus 4 minus 2/3 natural log of this factors into x minus 1 times x plus 1. College algebra is details everywhere. Now this is a product, and a product turns into a sum. And here's where you have to be so careful. I would have had to been just this careful too if I brought the 2/3 down in front. This is a natural log of x minus 4 minus 2/3. This guy right here will break into two pieces. The natural log of x minus 1 plus the natural log of x plus 1. This is 2/3 times this entity, but that entity can break into two terms. So that means it's 2/3 times whatever happens to this guy right here. Now, to clean up the problem, this is 4/3 natural log of x minus 4 minus 2/3 natural log of x minus 1 minus, because minus times a plus is a minus 2/3 times the natural log of x plus 1. Using the distributive property. Took the negative 2/3 through. Now this is something I want you to think about. The plus in front of the 4/3. And if I go back to the original problem, you notice that x minus 4 was in the numerator. It's got a plus sign in front of it. If I notice the minus signs in front of these two entities right here, if you multiply x minus 1 times x plus 1, that's x squared minus 1. Notice in the original problem, where was it? It was in the denominator. So when you've got minuses in front, that's going to tell you that thing's going to flip to the denominator. These guys, when you bring it back together, goes to the denominator. When there's a plus, it's going to be up in the numerator. Not a fun problem, but part of college algebra is getting used to handling problems that are very, 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 very detailed. Because when you get into calculus, the problems are very, 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 very detailed, unfortunately.